Hello, I'm Kenneth Chufa, and my student ID is 101523555. In this video, I'll walk through my IRIS multi-class classification assignment, explain the code, and answer the questions about neural network and overfitting. At first, I load the IRIS dataset from provided CSV. I use OSPath join and get CWD to build a file path and store in the file name. Then I read with the pandas into the variable called iris. The species column has text labels Setosa, versicolor, virginica, so I map the integers 0, 1, and 2. That's done with the dictionary and the map method. I split the data into features and label X is the first four columns, sepal length, sepal width, petal length, petal width, and Y is a species column. I use train test split with test size 0.2 and random state 123, which gives 120 training and 30 test samples. Because we have three classes, I convert the label to one hot encoding with two categorical. That produces vectors like 100 for Setosa, 010 for versicolor, and 001 for virginica. For the first model, I built a sequential network with three dense layers. The first two have 100 units and a ReLU activation. The input shape is 4. Since we have 4 features, the output layer has 3 units with softmax activation, which outputs class probabilities. I use categorical cross entropy as the loss because the labels are one hot encoded. I compiled the RMS prop optimizer and accuracy as the matrix, then trained for 20 epochs with a batch size of 10. This model reaches about 96.7% test accuracy. For the second model, I keep the same structure but reduce the hidden unit from 100 to 10. I compile and train the same way, but only 4 epochs. This model gets about 80% of test accuracy, lower than Model 1. That shows how more hidden units can improve performance on this dataset. Now let's get to question number 10. 10A1. How do layers and hidden units affect accuracy? More hidden units give the model more capacity to learn patterns. Model 1 with 100 units reached 96.7%, while Model 2 with 10 units reached 80%. More layers can help with complex data, but on small datasets like IRIS, too many can lead to overfitting. Too few units can cause underfitting. 10A2. Do we always suffer from overfitting? No. Overfitting happens when the model memorizes the training data and does poorly on new data. We can also have underfitting when the model is too simple. It depends on the model complexity and dataset size. Question number 10A2. How can we detect overfitting? Compare training and test accuracy. If training is much higher than test, we likely have an overfitting. We can also plot train and validation loss over epochs. If training loss keeps dropping while validation loss rises, that's overfitting. 10A4, how can we reduce overfitting? We can use regularization, dropout, early stopping, fewer layers or units, data augmentation, or more training data. Now let's come to 10B. For question 10B, I change one parameter at a time from the baseline model 2. 10B, experiment 1, optimizer. Switching from RMS prop to Adam gave only 20% of test accuracy with 4 epochs and small dataset. RMS prop worked better here. Now let's go to experiment 2. Here, adding a hidden layer kept accuracy at 80% more. Layers didn't help much on this small dataset. Experiment 3. Using 50 units instead of 10 gave 76.67%, slightly worse. More units can overfit on small dataset. Let's go to experiment 4. Here, training for 10 epochs instead of 4 improved accuracy to 86.67. More epochs helped the model learn better. Experiment 5. Using batch size 5 instead of 10, drop accuracy to 16.67. Smaller batches give noisier updates with few epochs that hurt performance. And here is a little explanation. So that concludes my walkthrough of the IRIS multi-class classification and answers to question 10. Thank you for watching.